Yeah, hi YouTube. Welcome to part two of testing the Russian theory of reverse charging a bad battery and hopefully turning it into a good battery and improving relations between the hemispheres of the world um, through through science, through the brotherhood of science. We're testing this Russian theory that was on YouTube, that you can reverse charge a battery and fix it. So here we are. In our last episode, we hooked up a bulb to a battery that read replace on our modern battery tester. And it is an old battery. It's been sitting around the shop for a while. It actually took several days to completely drain it using a tail lamp that was wired up to it in the last episode. But it did. It drew it down today. The bulb was out yesterday. Was it out? And and today is Saturday. So I put the meter on it, and well, first of all, it didn't have enough power to even power up my Foxwell tester, which I fussily keep in this plastic bag to keep it nice and pristine, so it always feels like the first day I got it. It's a nice device if you need one. It's the BT100 Pro. So, and then I hooked my Radio Shack meter to it, my classic Radio Shack discontinued meter. And with the bulb still on it, it was reading like 0.3 volts, like about a third of a volt. So there was still a little something going on in there. And then when I would take the load off of it, the battery would slowly start charging itself. And by the time I got done like prying the caps off, which I will get to, it was up to about 5 volts, but it probably had very little oomph behind it. So I figured it's probably good enough for moving along with the test. So as you can see, I pried the tops off using my pry bar set, which I'm very proud of. It's a beautiful set. That's a Wild, WILDE. You could buy the set, and then if you buy the set, order the Wild wood or the Wild tool, the holder. You got to have the holder. Isn't that cool? And it's always where you want it, next to the fire extinguisher, so you can grab one or the other when you're in a panic, because one or the other will fix any situation you're in, the fire extinguisher or the assortment of giant pry bars. So I use the pry bars to gently remove this. It's like a single unit that came off cleanly so I could reuse it. And when I looked inside, the electrolytes all looked really good. One was a little low, but the rest were consistent. We're just up to the where the plastic hits it, which would be like, the low range of, but still good. And the one on the end by what used to be the positive terminal, which was born positive. We're doing kind of I guess this kind of parallels a lot of like societal trends now, right? We're reversing the polarity of the battery from birth. So that last one right here, where my pointer is pointing, was down about a 1/4 inch below that, but way above the lead plates. So, the lead plates were not exposed to a drought or anything. So I broke out, before I did anything, I broke out another tool I'm proud of, which is the official distilled water thing. This refills the batteries to exactly the right level automatically. So it was fun getting to use that tool. So I filled them all up to where, they all took a little bit. So I did that, and then I broke out. By the time I did that, it was up to like almost 5 volts. The battery was replenishing itself, just being unhooked from everything. But again, it probably had very little oomph. That's a term you learn if you study electrical, the oomph behind the volts. Very little. So I figured it was probably okay to hook up the charger. So what I chose, I've got an arsenal of chargers here. I'm using this one here. That's a model PSC 12800A by Powersonic. I've got a bunch of these. They were part of a product I used to market for law enforcement, but let's talk about that another day. And it's just a 12 volt, very small. This is an 800 milliamp 12 volt charger. So it's probably the smallest official battery charger I have at 800 milliamps. So I thought we'd start with that. I do have pulse charger, for desulfating. I've got a lot of those in stock, again, from my old products I used to manufacture. But that's a 24 volt. So I didn't want to complicate things by like hooking up 2 batteries or anything, or even complicate it by doing 2 experiments in one. So we're not using the desulfating charger. We're using it's just a regular charger. It is a float charger, so it's not just a completely dumb charger, which I thought worried me at first, because I thought maybe when it detects a fault, which it is, you notice the red light is on it because the polarity is hooked up in reverse. I should have said that like 100 words ago. I hooked the charger up so the positive is on the negative and the negative is on the positive. It's exactly what you're always very careful to absolutely not do by mistake, right? Well, I did it on purpose. Again, to replicate the Russian experiment in the interest of science and world peace. So that's on there, and the fault light went on the charger. So I was worried, oh no, maybe it's going to like protect me from myself and not put out any juice. But I get a spark, and when I've got my Radio Shack meter hooked up, and it's reading right now 4.52 volts. And I think it's been steadily decreasing. Well, it just went to 0.53, but I think it's trending down. We'll see. It should be reverse charging and hopefully take it down to 0. I think. No, now it's 4.54. Well, wait a second. Maybe it's already reverse polarity. It seems to be going up, and we've got, now the charger, I did not reverse the polarity of the meter. So the battery is still positive. The battery has not reversed polarity, but the charger is. So that's kind of curious, isn't it? I wonder if the charger is putting anything out. I'm going to go back and look at this, and I'll determine whether I should get a charger that does not have a fault circuit. Now it's 4.61. It's kind of behaving like the charger's not hooked up to it. Even though I get a spark. And it's too premature to see any bubbling or anything, so that's not happening yet. Okay, well, that's enough for this episode, and then I'll chime in again and let you know how the experiment's going after we get it cooking and let it cook for a while, probably several days. Over and out.